NCM Learning Center.
Good morning friends. In this video, we are going to discuss about the DC machines concepts. For EEE department students, the electrical machines concepts are very important for any competitive examinations. Okay, so we will discuss. The listed 8 topics are very important in the DC machines concepts. In the part 1 videos, we will discuss the first 3. What is lab and wave winding concepts, and induced EMF equation, then torque equation concepts. In the part 2 video, we will discuss the types of DC motor and generator concepts and problems. In the part 3, we will discuss the efficiency calculations. In the part 4, we will discuss the remaining topics one by one. Okay. In this video is a part 1 video. In the part 1 videos, we will discuss what is lab and wave winding, then the concepts of back EMF equations and the problems, then torque equation. Okay. First, we will discuss the lab winding. Lab winding is a parallel winding. So the windings are overlapped. This is a diagram here. These are parallel one by one. So the windings are parallel. So number of parallel path is equal to number of poles. So P is equal to A, where P is equal to number of poles, A is equal to parallel path. Wave winding. Wave winding means say wave series winding. So this is the image of wave winding. Only number of parallel path is 2. Okay. So A is equal to 2. For the wave winding, number of parallel path is equal to A. We have series winding. For lab winding, number of parallel path is equal to number of pole. We have parallel winding. This is the concepts of lab winding and wave winding. Then we will discuss the induced EMF equation of DC machine. The induced EMF equation is equal to P pi Zn by 60A, where E is equal to induced EMF or EMF generated per parallel path. P is equal to number of pole, pi is equal to flux per pole, Z is equal to number of conductor, N is equal to speed in RPM, A is equal to number of parallel path. This is the equation. If you are able to remember this formula, just remember this. Otherwise, if you need the justification, we will discuss. If you don't want this justification, just skip. Okay. So, justification. According to electromagnetic induction, Faraday's law, induced EMF is equal to rate of change of flux with respect to rate of change of time. Okay. This is the Faraday's law. So, E per conductor is equal to d by t by dt. By t means total flux linked in the conductor. Dt means rate of change of time. Okay. So total flux linked is equal to flux per pole into number of pole. Okay. Flux per pole in number of pole. So we will get the total flux. So we may write by t is equal to flux per pole into number of pole. Okay. Then we need rate of change of time. Rate of change of time means the time taken to complete the one revolution. So N means number of revolution per minute. Okay, speed in RPM, revolution per minute. So it means that it takes N revolution in 1 minute. So we may tell it takes N revolution in 60 seconds. So it takes 1 revolution in 60 per N seconds. So time taken to complete 1 revolution is 60 by N. So substitute these values, we will get E per conductor is equal to P into pi, total flux. The time, rate of the time is equal to 60 by N. So we will get P by N by 60. This is the induced EMF per conductor, but we need the induced EMF generated per parallel path. So EMF generated by parallel path is equal to EMF generated per conductor into number of conductor per parallel path. So we will get number of conductor cancel. So we will get EMF generated per parallel path. Okay. So EMF generated per conductor means this value P by N by 60. Here number of conductor per parallel path. Number of conductors is equal to Z. Parallel path is equal to A. So number of conductor per parallel path is equal to Z by A. we will get EM generated by parallel path is equal to P by Zn by 60A. So another one important points, each TANCE have two conductor. If TANCE is defined, so the conductor will be 2 times of the TANCE. Okay. So number of conductors is equal to number of TANCE into 2. Each TANCE have 2. Okay. This is the justifications for the induced EMF equations. Then torque equation of DC machine. The torque equation is T is equal to K into pi into Ia. K means constant, where K is equal to P Z by 2 pi A, constant value. Just remember this formula. If you need the justification, just go through this video. If you don't want, just skip this video. So justification is, we know that power delivered is equal to torque into angular speed. This is a basic equation. For the DC machines, power delivered, what is the value of power delivered? Here power delivered is equal to voltage into current. So power delivered is equal to, here voltage means induced EMF, current means armature current, so E into Ia. Then angular speed, we know the relations between the angular speed and linear speed. The angular speed omega is equal to 2 pi into n. Here omega is equal to radian per second, n means revolution per second. So the angular speed in radian per second is equal to 2 pi n by 60, because n is revolution per minute. N by 60 means revolution per second. Here radian per second, the n by 60 is revolution per second, the 2 pi. This is the relations between the linear speed and angular speed. So substitute these values in this equation, we will get power delivered E into Ia is equal to torque T into 2 pi n by 60. So we know that induced EMF equation E is equal to P by Z n by 60A. Substitute this value, we will get this equation. Now simplify this equation, we will get the torque equations. Okay, just simplify, we will get answer P by Z Ia by 2 by A, where P is the number of pole, the constant, flux per pole will be changes. Okay, Z number of conductor constant, armature current changes, A number of parallel path constant. So T is equal to K into pi into Ia, where K is equal to Pz by 2 pi A. Okay, constant value. This is justification. Now we will discuss the problems. This question is asked in GATE 96 examinations. Here the given data is number of pole P is equal to given 4. Wave winding means number of parallel path. Wave means series. Wave seriously connected by number of parallel path A is equal to 2. Here then armature has 51 slot, each slot have 20 conductors. Then what will be the value of total number of conductor Z is equal to total number of slot into number of conductor in each slot. For example, number of slots is equal to 3, each slot have 2 conductors. Then what will be the value of total conductor? 3 into 2, 6. Similarly, okay, so here number of slot is 51, number of conductor per slot is 20, so we will get number of conductors is equal to 1020. Then induced EMF is given, E value 357 volt, speed is given n, revolution per minute n, 8500 rpm, but we need the flux per pole pi. We know that induced EMF equation E is equal to P by Z n by 60A. If you know this equation, we can solve this problem very easily. Just substitute all these values in this equation, we can find the flux per pole. So E is equal to 357, number of pole P is equal to 4, we need pi value, Z value 1020, n value 8500 rpm, 60 into number of parallel path A is equal to 2. So just simplify this equation, we will get answer pi is equal to 1.2 million Web. So option B is correct. Now do it yourself. Okay, 2 problems given. Just try, comment your answers. If you have any doubts related with the discussion, just post your doubts through our NCM Learning WhatsApp group. We have an Android app, just use this Android app. All the materials are available freely, just use. Definitely you can get the good marks in the competitive examinations. Okay, this for first question C 384 volt, for the second questions 700 volt. Okay, good, thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.